the last outline of the day, which we call reliability. And what do we call reliability? Of course, reliability is concerned with the performance and conformance, okay, over the expected life of the products. You know, we have been using a product, and how reliable is our product? Of course, we need to know that because we don't want an item that we fail suddenly. Okay, if an item fails suddenly, imagine I'm driving a car and the car gets stopped. Okay, and maybe that happened in the middle of the highway. I'm not going to like that kind of situation, and that is the reason why we actually need to know how reliable, is this component that we use from day to day. And we don't really expect the the efficiency of item to be 100%, because the day you purchase it is going to be decreasing. And that is the reason why, for you to be able to know when to replace whatever item you are using, then you actually need to know how reliable it is. Now, the reliability today, the definition asks for important elements, but you know what? We're going to focus on the probability aspect. Why do we want to focus on the probability? Is because we live in a world where anything can happen. What is the probability that as I'm driving, my car is actually, maybe the tire of my car is going to get punctured or it's going to be deflated and something like that. So what is the probability that that is going to happen? And that's exactly what we want to talk about, because this is a probability class. But let me tell you, the facts remain that there are other definitions that has to do with time, because whether an item is going to fail or not, it depends on time, okay, and so on like that, the operating condition and so on like that. But you know what? We want to actually explain reliability in the concept of probability, okay? Of course, you know, the value of a probability is between 0 and 1. I think you know that, okay? Now, the probability of 0.97 means 97 out of 100. I think you know that, okay? Which you can also call 97%. We are in a world where we actually want to have a guarantee, okay? We don't want a sudden failure, okay? Now, so if you have 97 out of 100, then items will still be working at the stated time, okay? That's a very high probability of reliability, okay? Now, understated condition. Now, you know what I want to talk about right now? I actually want to, we have different kind of system, okay? If I'm talking about system reliability, I actually need to know the nature of the system I'm talking about. Am I talking about series connection, or I'm talking about parallel connection? For those of you who have done physics before in the high school, you must have come across something in physics where we say resistors in series and resistors in parallel, okay? But right now, we want to look at reliability, okay, of a series system, okay? And this is the way the series system look like. Are you guys still hearing me?
Yeah,
Yes.
yeah.
Okay, now if I have a series connection, how can I actually determine the reliability of the system in a series connection? And you know what? If R1 is the reliability of system 1, and R2 is the reliability of system 2, and RN is the reliability of system 1, then the reliability of a system is just the product of the reliability of the respective components. I'm actually going to give you an example right now. If I'm driving, of course, car has a car has 4 tires. If one of my car is punctured, it will affect the functioning of the car, because the car can never work on 3 tires. Okay, so which means in a series arrangement, if one, if this particular subsystem fail, it will actually affect the rest. Do you know the only bailout that I'm actually going to have? The only bailout that I'm going to have if I have a spare tire. And that is the only condition is if my spare tire is working. And which means the tires that I have on my car and the spare tire, they are not related, in terms of series, but they are actually related like this in parallel. Related in parallel because if one system fail in parallel, it's not other, the system will still be working. Okay, the system will only fail entirely. For instance, if I'm driving on the highway and one of my tires actually get punctured, of course, and if I think it happened to me before in Africa. I was driving and then my tire got punctured, and I wanted to look at my spare tire, to change the tire. When I get to my spare tire, the spare tire is even bad. That's a problem. Okay, that's a really problem. Okay, but in a situation where the spare tire is good, then I actually have a bailout. Then it means the tires I have on my car is actually, is in parallel to the one I have. I mean, to the spare tire. Now, what I just wanted to know, when you have a series connection like this, if you want to determine the reliability of the system, you just need to multiply the the respective reliability. But if you want to talk about that in parallel, what you're going to do, this is a formula for parallel. It has to be 1 minus R1, 1 minus R2 up to 1 minus Rn. Okay, so I'm just trying to give you the formula right now. But do you know what? Do you know that if I'm talking about two systems, if I'm talking about two components that are arranged in parallel, if that means I'm going to have 1 minus into bracket 1 minus this and 1 minus that, if I expand that, it will lead to the formula of non-mutually exclusive. I want you guys to try that. When you have two components that are in parallel, okay, and you apply the formula here, because the formula is actually going to be 1 minus R1 and 1 minus R2. If I'm talking about two components, by the time you expand that, it's actually going to give you the same formula that I gave you before under non-mutually. Okay, that's exactly what you're going to see. Oh, somebody said that is actually really interesting. Yeah, it is interesting. You can decide to expand that how. Okay, now we can have a situation where we're going to have the combination of series and parallel connection. But you know what? If you take a look at this, they are in series. But if you take a look at it, these are in parallel. If I give you a question like this in exam, where I give you a value, I give you a figure for the reliability A or reliability B and so on like that, you need to first start from here. You need to first combine this. This is in parallel. And how do I combine this? What am I going to do? I'm actually going to use it. Look at that. I'm actually going to do 1 minus RC, that is 1 minus whatever I have here, and 1 minus whatever I have there. I'm going to multiply them, and I'm actually going to subtract from 1. The result that I have right now is this has now been resolved to look like this. Therefore, what happened to all of them now? They are now in series. And as they are now in series now, I can multiply this by this and the reliability here and this one, and I'm actually going to have the reliability of the system. Okay, so like I said, if you have the combination of series and parallel connection, you need to start with the parallel connection. You need to first resolve the parallel connection, to be like a, to be like this, combining that, so that when you combine that, instead of you to have a single a two component, you're actually going to have a single component. And this is a formula to go about that. Okay, and at the end of the day, you have a series connection now. Then you can multiply all the reliability to know the reliability of the system. Okay, what is next? Actually, what is next is permutation and combination. And that is going to be, we're going to do that on Monday. Is there anyone who want to ask question before I go today? Is there anyone? Any clarification?
I missed it a couple of slides ago. What is the equation for a series system?
Oh, the equation for series is just the product. I'm going to show you now. Look, can you see that now?
Thank you.
Okay, so it's just multiplying. If you're giving reliability here and here, you just multiply all of that. Okay, so that is it for series. But for the parallel, of course, you're actually going to have this. This is equation for parallel. Okay, And like I said, if you're given two sub components, okay, that are parallel, if you try to resolve that, you're actually going to have non-mutually. You're actually going to get a result that look like a non-mutually. Okay, so that is exactly. And uh, I think let me see. Give me 1 second. Give me 1 second. Now, can you guys see my whiteboard right now?
Yes, yes, you can.
Now,
Yes.
what? Thank you. So, what I'm trying to say in essence is that if I have something that look like this, if I have a kind of picture that look like this, and let me call this A and let me call this B, they are in parallel, and I actually want to obtain, uh, the reliability. Let's say this is let me say that the reliability of this is the reliability of A and the reliability of B. Okay, and I want to find what is the reliability of the system, because of course these two components make up the system and they are in parallel. Of course, I'm actually going to do 1 minus 1 minus RA, then 1 minus RB. Okay, because if so, next time maybe what you're going to be given is going to be, okay, maybe the reliability here is 0.8 or b is 0.7. Of course, you're going to plug that in. Now let me expand this. You're going to see what is going to happen now. 1 minus into, now 1 times 1 1, 1 times RB, that's going to be RB. This multiplied by that, that's going to be that. This multiplied by that will be plus RB. Now look at, can you see that expansion right now? Now, if you take a look at the expansion right now, let me continue. I'm going to continue right here. I'm going to continue right here. Now, RS is equal to 1 minus, open the parenthesis, minus 1. That's going to be plus RB, right? That's going to be plus RA, and that is going to be minus RB. You can see that now when you try to expand that. Now, plus 1 cancel minus 1. What is RS? RS is just going to be RA plus RB minus RB. What does it look like? It's looking like the probability of A union B equal the probability of A plus probability of B minus probability of A intersection B. Is that not mutually? That is not mutually. That's what we call non-mutually. So it means if you have, you know, uh, components that are in parallel, of course, it's actually, somebody said that blew my mind. Yeah, mathematics is very interesting. Very, very interesting. Can you see that now? So which means the parallel connection, when you have two events and you try to find the reliability of the system, when you try to do some mathematics, it will actually lead to non-mutually exclusive event, and that is the reason, that is what I just demonstrate right now. Is there anyone who want to ask question before I go today? Is there anyone? Somebody said, will the last few slides be uploaded to Canvas this week? Uh, yeah, yeah. I think these are the, I'm still using from, I think you can check the module. I've uploaded this material. There's another material that I'm going to upload. I'm going to stop my I'm going to stop my share right now just to be able to. I have another material that let me see if I. It's also going to be interesting. It could be like a practice material. Let me check. Let me check from here. Uh, Give me 1 second. There's another material that I'm actually going to upload. There's a practice questions on reliability. Okay. Let me see. Give me 1 second. I'm actually gonna. Okay. Can you guys confirm if you're seeing this material right now?
Yep.
Yeah, we can see it.
Yeah, I'm actually going to upload this to the module, and let me just show you what you have in the material. It's like that. Can you see that now? And the material actually have, look at that. Look at the example. Okay, you are giving figures. Okay, so look at that. So I'm going to attach that and take a look at this guy here. Can you see this guy here? This time around, you know, you are giving values, right? Power supply, PC unit, floppy drive A, floppy drive B, hard drive C, laser printer, dot matrix printer. You know, this is what we have in the system. How can we tell about the reliability? You know, maybe you are in an office that you have different kind of stuff like this. Okay, and you don't want a sudden failure. You don't want to disappoint your customers. How can we tell about the reliability of this system? Okay, so of course, if you really want to tell on the reliability of the system, you need to first, you need to first resolve this one. You know, the one you need to resolve the one that are in parallel first, and the one that are in parallel first. I mean, you need to first resolve this one here. Okay, and you also need to resolve this one. Okay, so that you're actually going to do. Let me give you a clue. You know, you're going to do 1 minus 0.98 multiplied by 1 minus 0.98 multiplied by 1 minus 0.95. Then whatever you get, you multiply, then you subtract from 1. So what I'm trying to tell you right now, if you want to resolve this one now, you're going to do 1 minus 1 minus R1. Okay. Then 1 minus R2. Okay. Then 1 minus R3.